Hello. Thanks everyone for coming, and thanks to the cafe for hosting us. Thank you also for still being here. I'll try not to be too long. So I'm just going to talk very quickly about Anoma Endgame. And the basic thesis of this talk is that some of you may be working on Anoma, or some of you may know people working on Anoma. And you may be wondering, like, what is it exactly that these quirky people are up to? They seem to be doing a lot of things. You heard about Namada, but you heard about this thing called Ferio. Ferio is not part of Namada, so why are they working on it? You might have talked to Jeremy, who's working on a language called Alucard. What does Alucard have to do with anything? It all seems like rather confusing. I was joking to someone last week that Anoma is a zero-knowledge project in the sense that we can't quite say what it is, but we can provide proofs that things are part of Anoma, right? So jokes aside, in this very, very short talk, I'm going to lay out very quickly what Anoma is and try to break it down and explain why we have defined it this way as opposed to defining it some other way. And then I will sort of very quickly arrange some of the features of Anoma you might have heard about in time, which might make it helpful to see how they all fit together. So if you go to, for example, Twitter or a website, you will see Anoma defined like this. Anoma is a suite of protocols and mechanisms for self-contained and self-sovereign coordination. I'm not sure what this sounds like. Maybe it sounds like a slogan, but it's a pretty bad slogan because it has a lot of words, and some of them are hyphenated. So if they were designing a slogan, they did a bad job. Maybe it's they wanted to sound buzzwordy. It has self-sovereign. Self-sovereign sounds good. Who doesn't like self-sovereign? What does it mean? I don't know. No, this is actually a definition. And it's a bit of an unusual definition for a blockchain project in particular, because it's not a definition of we could say Anoma is like a blockchain and has this feature. And it's true that Anoma has parts which are that thing, but we don't define Anoma that way. And the reason we don't define Anoma that way, I will get to the reason in one more slide. Let me just say quickly some things that Anoma is not, just in case it was interesting. Anoma is being censored. OK. Anoma is no longer being censored. What is Anoma not? Anoma is not a blockchain. It's a protocol. Anoma is not a token, and it's not a company. Anoma is just like an open source software project that includes all of these protocols, and they're designed to fit together, and they're built by a company called Heliax, and they are coordinated in part by a nonprofit called the Anoma Foundation. But Anoma is not any of those things. Anoma is just a project. So why do we use this definition for Anoma? Why don't we say Anoma is this X technology, but we changed Y thing? The reason we define Anoma in this way is that we think technology is a tool. So it's easy, by comparison, to take something that we all know and love as a very good tool. So if you think about a hammer, what makes a hammer a hammer? It's not the specific composition of metal. It would be odd to say that this specific iron atoms configured in this way. If you define a hammer like that, people would look at you like you're rather mad. Because why would you want a hammer? I mean, I don't want to be rude. There might be some people in the world who are really into hammers, and they study hammer designs, and they think all their day. They spend 40 hours a week thinking about what are the hammers, what kind of hammers are possible? How do we make a better hammer, right? This is Anoma people, right? Okay, but technology is a tool, and for the rest of the world, tools are defined by what they are for. What makes a hammer, that you can hammer stuff with it. You really want a hammer to be good at hammering. It doesn't need to do anything else. If it does other things, those are externalities of hammering. If you have a hammer that emits carbon, that's a very odd hammer, right? Okay, so if you have an economic system that emits carbon, yeah, you get the metaphor. All right, tools are defined by what they are for. So that's why we've defined Anoma in that way. You see the word for in this sentence? For self-contained and self-sovereign coordination. So these are very abstract words as opposed to a hammer, which is very concrete. You can hit stuff. So I'm going to try and break them down a little bit. Right, so there are two sides to this definition. The first I'm going to call the concrete definition, and the second I'm going to call the functional definition. So if we take the hammer comparison again, hammer is like a physical thing. There's a handle, and there's a head to the hammer. I think that's what it's called. Obviously, I don't spend a lot of my life using hammers, but I've done it. So the first side is what I'm going to call the concrete definition, like the head of the hammer and the handle, right? So Anoma is a suite of protocols and mechanisms. There are other things you could use for coordination. Coordination is a very useful thing. For example, language is something that we use for coordination. Anoma is not a natural language. We are not accidentally inventing Esperanto. Okay. Anoma is a suite of protocols and mechanisms, like an information system, and it's somehow split down. That's a lot of words. So why? Get to that next slide. And it is designed for self-contained and self-sovereign coordination, also a lot of words. So if you think of a hammer is like a physical thing with a handle that is for hitting stuff. Okay, so number one is a physical thing with a handle, and number two is what it's for, hitting stuff. Anoma is defined like this because Anoma is also a tool. It's just a more abstract one. Cool. So let's take the first part of this definition first. a suite of protocols and mechanisms. There's some contradiction built in here. That's intentional. So you could say like a suite. That's a singular thing. So it's like one something, one suite, whatever a suite is. Sounds like a hotel room. And it's composed of protocols and mechanisms, which are plurals. They're different things. Right. So why? The basic reason why is that we think Anoma needs to be integrated because users care about a tool in like an end-to-end way. You care about that the hammer and the head of a hammer are attached to each other. If they're not attached to each other, not so useful. And they have to like fit. One has to fit in the other. If it doesn't fit, you have two interesting parts, but they're like not good for this thing of hammering that you want it to be doing, right? So the protocols and mechanisms need to work together for coordination. But also they are separate. They're modular. If we tried to build like one single, it's like using one single atom or something to hammer. It doesn't work super well. We want also to, Anoma's kind of complex, and there are lots of different parts, and many of them need to be built by different people, and if we had like only one thing and never split it apart into different components, we would just never be able to do anything. So it needs to be modular, but also integrated. Hence, a suite of protocols and mechanisms. Then self-contained, self-sovereign coordination. What's that all about? So self-contained relates to that sort of the way that the space in which we're designing this mechanism has adversarial actors. In informational space, I'll say what that is in a second, trust is local. So what do I mean by informational space? Informational space in the context of coordination is basically like who you talk to and who you're coordinating with. So if you didn't ever use the internet, your informational space would be also physically local. Like you would talk to the people who were nearby. If you use the internet and use remote communication technologies, your informational space is probably partially physical and partially remote. Sometimes you're talking to your friends far away, sometimes you're talking to your friends nearby. In any case, you trust people who you like talk to a lot. So the informational space is local. But if we're building like sort of complex systems for coordination, potentially with large numbers of people, then adversarial actors are going to go after like the weakest part of those systems. So this is why we want to think about things as end-to-end. So we need to consider the system as like a self-contained whole, which provides this function of coordination. Right, self-sovereign. So we talked about mechanisms and protocols. And we are, in the design of Anoma, trying to design a suite of mechanisms and protocols which is self-sovereign, which means basically that there's not a stratification of people using the mechanism and people controlling the mechanism. So if you think of some mechanisms that we use for coordination right now in the world, like currency, there's this like very, very distant stratification between most of the people who are using currency and people who decide the rules of the currency. And that seems to cause a lot of like incentive alignment problems writ large. So similarly, why there's kind of a unified reason for why we're doing this, where what is the problem? Like why is it a bad thing to have a mechanism which is used by some people and controlled by some other people? Because like sometimes people are adversarial or just like don't know other things or are somewhat self-interested. And similarly, trust is local and informational space. So we want the people who are using the mechanism to be able to control it themselves, not be reliant on someone else to operate it on their behalf. So another question you might ask in the context of trying to figure out what is happening in Anoma is, what does it mean for such a system to be complete? Like, when will they be done doing this weird thing, and can I check if it's like interesting to me? So for us, that means that we want to finish this thing end-to-end within the space which it solves. The ends are human, right? The ends of a coordination system are the people actually making decisions, despite what you may have heard from like OpenAI, computers don't make decisions. The ends people making decisions, at least that we're concerned about, are human, and that's why when we like say something like vertically integrated or end-to-end, we mean that, as you saw in the wallet presentation earlier today, we build a wallet, which is like what a human interfaces with and thinks about, and everything in between that interaction in the wallet and another human in another wallet or another interface somewhere else. And we're trying to think about the whole problem because any adversarial actor is going to go after the weakest link in the problem. So an example of where this like comes into play is if we're using some fancy cryptography to do fancy cryptography stuff, and it involves polynomials, and it involves zero-knowledge proofs, and it involves all of these other things. Not everyone using the system is going to understand that fancy cryptography as much as we might love to talk about it with them. Some people have other things going on in their lives. We're trying to accept this. So we're trying to design interfaces which provide a like intuitive conceptual mapping in the user interface elements used to what's actually going on, and which preserve, for example, people intuitively understand the privacy properties, say, of cash, that when you pay someone in cash, you know that you're paying them, you know how much you're paying them, and they also know, but no one else knows, right? That's very intuitive. When you use your credit card to pay, it seems like that's happening, except it's not, because the system is a lie, and it's not respecting the intuitive notions of information locality that you reasonably expect. So what is coordination? I talked about this, so I won't talk about it too much. Switching to mutually preferred states of a system. This definition, although you might not think that it constrains the design space, I think it actually constrains the design space almost completely, in that coordination starts from intents. What state of the system would actors prefer? Which states of the system are actors capable of enacting? And from intents, we go all the way to like how Anoma is split up into different protocols. From intents in the case of front-running and Fairview, we go to how do we ensure some kind of fairness or prevent someone from exploiting asymmetric information. Everything in the Anoma design starts from this sense of intents of coordination. So that basically requires that we split what's happening in the information flow of the protocol into two phases. The first phase is just like once we have these intents, if people want to like change the state, they need to figure out if others are interested. So that phase is counterparty discovery. And in Anoma, this is handled by intent gossip and matchmaking. And the second phase is settlement. So if we've like figured out that some people all agree on updating the state and they are all capable together of doing it, then we just update the state. Right, so we want to do these things and we want to minimize externalities. So what are externalities? Externalities is like anything else other than what it is that you wanted to do. So hammer, if you hammer a lot and you like hit your thumb by accident and your thumb bleeds, that's an externality of the hammering. I don't know how to get rid of that externality, but be better at hammering. Right. How is privacy relevant? You might have also heard things about privacy and wondered what that relates to coordination. So non-privacy creates externalities. When you pay with a credit card and you wanted to get coffee and pay $5 and instead you get surveillance capitalism, that's an externality. And why? In part because non-privacy creates all this data that's floating around and the returns to sophistication, and companies can optimize advertising and do all this like kind of silly stuff. I don't know why they do it, but it's profitable, unfortunately. So anyway, Anoma is just designed so that you don't need to create these externalities unless you want to. And there might be reasons, if you think about like when you're discussing with people and you're coordinating things, a lot of the time, you're planning dinner with friends, you don't really want to announce that to the world. Like maybe you would, if you announce that you're going to buy a car with your friends, maybe the car company would realize they can maybe charge you a higher price. I mean, there's weird stuff. Also, it's just like not by default the thing that happens, but sometimes you do want to announce things. Sometimes you want to announce that like you are interested in starting a political party, right? And you want to announce that to the world. Or sometimes you might want to announce as a company or foundation that you're committing funds to fund particular things to try and create market incentives. There are reasons why you might want to publish things, and Anoma gives you that choice too. It's just a choice instead of it being some externality of the interaction which you didn't want. Right, so what is out of scope? What is like Anoma not doing? Anoma is not doing anything related to semantics. Computer systems can't tell you what to want. They can't. A hammer cannot tell you what to want, nor can a computer or an information system, despite what OpenAI might be saying. It's wrong. So what about, why would you even care about, if the system itself is imaginary and you're just coordinating on changing the states of imaginary systems, this sounds sort of like a fancy game. What relates it to the real world, especially if you think that maybe you care about stuff in the real world other than imaginary systems? So what relates, is Anoma solving the Oracle problem? Sometimes I get this question. Well, what does it take to solve the Oracle problem? What is truth? Can't answer that question in my slides. Sorry, go to the philosophy talk instead. But we might say very hand-wavily that truth is grounded in some kind of observation. Like, what is it for, something to, if I see some news article, what actually makes the thing in that news article true or not? It's some causal chain from someone actually observing the thing, like a fish jumping out of a river and turning into a man and starting to talk about polynomials. And if they really observed that thing and maybe other people verified that thing, then I guess it's true. Haven't seen that yet, but could happen. So another thing that is perhaps a characteristic of truth, which we might care about, especially in the context of designing coordination systems, is that it's unique. There's only one truth. Say the temperature in Amsterdam. Temperature in Amsterdam, I think we can all agree, even if we don't agree on whether it's 10 degrees or 11 degrees or 12 degrees or whether we want it to be something else, we can agree that it's right now the temperature is something. I mean, modulo atoms moving around in slightly non-homogeneous ways, but there is one temperature in Amsterdam. We could agree on it within air bounds. So it's unique. This is a very helpful property of truth, that it's unique. Otherwise, we wouldn't be able to hook it into these systems in any particularly interesting way. But it's unique, so Because a protocol is a deterministic information system, it cannot tell what is true. Like, it can't. If someone tells you that a blockchain, incentivizes carbon sequestration, a blockchain incentivizes people that are lying, or they're like being very lazy, because a blockchain doesn't know anything. It's just an information system. But it can, if there are multiple actors involved, it can reward agreement between those actors, or it can create a sort of subsystem whereby those actors have to commit to what the temperature in Berlin is, or they have to time lock encrypt it or something, and later they reveal it. And if they wanted to agree on the same thing, then because the truth is unique, the easiest way for them to agree on the same thing is just to say what they observe, if the truth in this case is actually true. So yeah, that's the most any distributed algorithm can do about the Oracle problem. If you put garbage in, you will get garbage out. Blockchains, insofar as they relate to the world, are a pretty cool spreadsheet. So, that may sound like a pretty cool spreadsheet, can't do much. In some sense, that's true. On the other hand, we have some weird distributed, partially controlled by different people money spreadsheet, and it seems to somehow cause us to do things a lot. Don't always know why, but it does. But either way, just as money is an incentive only if you want it, what the blockchain does or says is an incentive or relevant to the world only if people decide that it is. So it's based entirely on social consensus. Right. Sorry that I'm slightly jumping here, but another thing I wanted to tie in is fractal instances. So Anoma has this idea of fractal instances, which you might have heard about, where different people are operating different instances of the same protocol. Maybe there's one for Amsterdam, one for Berlin, one for your 5 friends. Why? And why is Anoma doing this instead of something else? Is the sharding? It sounds like it's sharding, but maybe they renamed it something fancy. No, it's not, actually, but it is a bit close. The architectural thesis of fractal instances is one of, I would say, a slight contrast, but maybe it will make sense after the slide. And the contrast is that of a standardized modular architecture, but heterogeneous security. So why would you want a standardized architecture? It sounds like it's modular, but there's some kind of sameness going on there, but heterogeneous security. Why? So another thing you could do is you could have homogeneous security. And the people who, if people are saying that there should be one blockchain or one single location of data availability, one single location of trust, that's a homogeneous security system. Homogeneous security systems have advantages. They're simpler. Maybe if you have everyone use the same system, its security levels can be higher. But at the same time, they create a single point of failure, both in the sense of if there's an asset relevant to controlling the consensus of the system, then anyone who co-opts that asset can co-opt the whole system. Also in the mechanism sense, if there's a mechanism like proof of stake that's designed to protect the security of that system, then that mechanism is the thing which everyone will be targeting. It's just a massive honeypot. So it seems like it might be more secure to have a heterogeneous system that can fail, in little parts, but not fail all at once. But many communities want similar things. They want barter, they want monetary units count, they want public goods funding, but trust is local. Hence, heterogeneous security with this homogeneous architecture, in some sense, to provide all these things. So what is the end game of fractal instances? How would you think about, in 10 years, how are you using fractal instances? The answer, honestly, is that they're kind of boring. I mean, when you open Google Sheets and you make new sheet, most people don't think this is the most exciting thing that happened in their day. It's just there and it works. And unfortunately, you have to send your data to Google. Don't do that. But luckily, in 10 years, you won't have to if you wanted to use the sheet to coordinate who's paying for dinner, let's say. So the end game of fractal instances are things that some of them live long, some of them don't live long, but some of them could live quite short. Or say you have in college, you have 4 other friends. There are 5 of you in total, and you decide you want to start, a sort of secret conspiracy, right? So you put all of your phones on the same table, and you do some key exchange. You start a new fractal instance. Maybe it's a quiescent one, which produces blocks on demand, so it's not consuming too much bandwidth all the time. Then you have no one else needs to know about this, and all of your data from this point henceforward is encrypted when it's sent around. Then you have a fractal instance. You have your own self-sovereign jurisdiction. You could do contracts with each other, just promising people things, except now you have this shared spreadsheet to write it down in. And you can also interface externally as this point for collective action. But this is only binding as long as you want it to be. You could decide that you don't like it anymore and give it up. Just as sort of committing to people are, is just a nice way to track that. So, all right, all of these abstract things, Very interesting, but when will there be anything useful, and how are these components organized in time? We've decided, well, so far, tentatively, but hopefully, to organize the sort of, let's call it coalescence of the Anoma protocols into 3 major release lines. Each of these release lines is focused on different forms of coordination. Each is designed to be independently testable as an end-to-end product. So like even if you didn't care about the other things, like the ones involving polynomials, well, sorry, all of them involve polynomials, but they involve different polynomials. If you didn't care about some of the polynomials, you could use like only v1 or only v2 and only v3, and you don't need to understand the whole system. Great. So the v1 release line, which will also be relevant to Namada, the fractal instance being launched, is focused on just providing private monetary units account. Seems like kind of simple, and why has no one done this already? And honestly, we ask ourselves the same question. It seems like, that was kind of what Satoshi was going for. Of course, ZKPs weren't around yet so much, but it just doesn't exist. Like I can't go in Amsterdam and pay someone privately using my phone. I still have to use my credit card. We're all at these fancy crypto conferences. It's been, 10 years. We're still using our cards. Yeah, it just doesn't exist. So we're going to release that. It also has some privacy bootstrapping incentives. It's very hard to design those, but we tried to strike this nice balance, try them, see how they work out in practice. Plus, proof of stake, Tendermint, governance, interoperability, good stuff. Summer 2022, hopefully. Then after that comes V2. V2 brings end-to-end private bartering. So let me note here the distinction between protocol versions and fractal instances. So V1 is a release line of the Anoma protocol. And that line of the Anoma protocol can be deployed by anyone to make a fractal instance whenever you want. We will sort of help with the deployment in the form of Namada. Namada is an instance, right? So the protocol called Anoma, Namada instance. V2 release line, hopefully, yeah, that may be a very optimistic timeline, but let's say that there will be testnets of V2 on first versions of V2 on this timeline. We'll bring end-to-end private bartering, transparent multi-party auctions, public goods funding, other things, and that includes particular interesting subcomponents that you might have heard about. Fairvio, the threshold key generation, the distributed key generation and threshold decryption system that Jacob gave a talk about earlier. It includes Typhon, the consensus algorithm that we're working on, which supports atomic cross-fractal instance transactions. It includes Taiga, the circuit and system for private bartering and private state transitions, and it includes what I've come to start referring to as the J group, which sounds like a star cluster, but it's actually a language cluster. The J group includes Juvix, high-level dependently typed language. It includes Alucard, and it includes Vampr, the circuit DSL. And all of those connect in hopefully a coherent way that we are still figuring out, but it's looking moderately good. Then the V3 release line will bring the really hard crypto, which we haven't figured out how to do yet or benchmark very much. In order to, ZKPs limit you to basically single user private state because someone has to know the state to create the proof. That's how you get privacy in ZKP architectures. So in order to do multi-party private state, which you might want for things like private auctions or multi-party private public goods funding, and also to do things like having privacy for everything, but occasionally pulling economic statistics out of your system in a way that doesn't de-anonymize users, just reveals aggregates. We need to do more things like multi-party computation. So the V3 release line, which is coming eventually, soon-ish, will feature multi-party private state transitions using some FHE and MPC cryptographic subprotocols in different configurations for different things. Then maybe we're done. Afterwards, we've gotten all the flavors of private state transitions. We can do single user private state. We can do multi-user private state. We'll keep optimizing things until you can actually run fractal instances on your phone and validate them. Not yet, but coming. We'll keep working on the protocols. We'll decentralize. I mean, Anoma is kind of now, they're like not that many people who know how it works. You don't want to have a tool where not that many people know how it works. If you were all using hammers, but they were like magic hammers, and they had these button configurations that nobody understood, and if they broke, you could never fix them, that would be very dangerous. Similar thing, Tesla cars. But we're going to try and help decentralize knowledge of how the system works just by talking about it, explaining it, all open source. Yeah, we can use it. Relax, take hikes. Thank you. Any questions? That was so clear, everyone just understands it now? I don't believe that.
Hi, Chris.
Hello.
Do you have any plans for talking with integrators after you have the bartering up and running, talking to people to provide liquidity in this market, all that jazz?
Uh, I would say, yeah, absolutely, and also it depends on who you mean by you. I mean, we build software, like at Helix and the Anoma Foundation fund software, and we can't, we are not, the stakeholders of the system own the system. But in principle, I would say, I guess to give a more granular answer to that, I would say that we view our role as like providing software not just limited to cryptographic components, but also including the practical components at the edges of the system, which are like necessary to do things like report your taxes if you're sending shielded transactions, or integrate it with other kinds of software suites with different protocols, or write your own interfaces which use it, or connect your existing kind of backend systems to it. All of that is within scope. Yeah, hopefully that makes it easy. Of course, there's no, Helix doesn't operate Anoma or Nomada or any of these things, so we can't like sign contracts to do that thing, but maybe we could help with other things.
Sounds good.
Other questions?
Can you talk more about heterogeneous security? Like elaborate on it. Why doesn't it exist today? Barriers?
Right. Why doesn't heterogeneous... So heterogeneous security kind of exists. A system like, say, Cosmos with different different blockchains are heterogeneous security zones. Often there's a lot of overlap in who is actually running the validators for economic reasons that may or may not spell the demise of proof of stake, but jury's still out. I think one part of heterogeneous security that to me is very important that we haven't seen yet is sort of cross-finalization. So right now you get like the weakest, what if you use many blockchains in some kind of cross-blockchain interaction, or many separate security zones in a cross-security zone interaction, you get the weakest of those security zones. While some of that will always be true, we can also do a sort of, when we're crafting an interoperable system, we can have not only individual parts of the interoperable system come to consensus on their state, but also the rest of the system come to consensus on the individual part state without relying on it. It's just like two layers. So we can do a sort of, you could think of it as like a multi-phase commit on the other security zones as to what one security zone said. We need to do this anyways for interoperability. And then you, as someone running a client, can say, I want to check like what these validators said, and I want to check what these other validators said about what the first group of validators said. And if you have finality in such a like heterogeneous system, it quickly becomes very difficult to convince clients of some fork, because not only would you need to like co-opt one proof of stake token and mechanism, you would need to co-opt like 50, and they're different. So I think defense and depth of heterogeneous systems is a possible design space that has not really been explored yet, because consensus is hard, and because consensus is like on the down wave of being super, trendy. But we're interested in it anyway, and probably there'll be an interesting upwave. Other questions? Any objections?
Hey, how's it going? Whoa. Hey, how's it
Hello.
going? I have two questions. The first one is probably pretty easy. This has been a great conference, and this has been a great talk. The one thing I haven't heard about at all week, which has been refreshing, is about NFTs. So I'll just ask the simple question, which is like, can Anoma is NFT, you can have NFTs on Anoma? Or V1 or V2 or V3?
Right. That's a good question. You absolutely can have NFTs on Anoma. Anoma is very unopinionated about what the state on the system means, back to my slide on semantics. And we have sort of forms for NFTs if you'd like to do that. In Nomada, you can send NFTs around privately, but you can't really do anything else. Still, that might be a useful thing depending on what the NFTs are. In V2 and V3 of the protocol, you can barter the NFTs privately.
Cool. Number two, so like I think about Anoma a lot, and when I think about it, it's like it seems like the architectural design of it is pretty far ahead of where people are thinking about the space, where transactions can, like how transactions will occur, how people will communicate and transact with each other. And so like I think about like maybe it's 5 or 10 years ahead of like where things are right now, right? And so when I think about that, I think about like, all right, what else is 5 or 10 years out? And AI is like the first thing I think about. And intents seem like a thing that AI and intents are an interesting combination of how those two things might be able to work together or may not be able to work together.
Right.
This is more open-ended, but like, what do you think about that? What do you think like some of the possibilities are for like AI on Anoma?
That is an interesting question to which I'm going to give maybe a kind of contrarian answer. I think AI is dangerous, especially in the framework of like advertising and sort of profit-driven capitalism without much effective collective rule set control that we have right now. I think in primarily AI is dangerous because there's a lot of data floating around, and as AI algorithms get more sophisticated, they can do more processing on that data, and it's very asymmetrical because some people have super fancy AI algorithms and the rest of us don't, and some people have all the data on their users and the rest of us don't. I mean, even if all the data were public on like a chain like Ethereum, most people don't have tens of millions of dollars to run like computers to run regression algorithms. So I would say that I'm very interested in making more things private so the AI can't compute over it and like somehow come up with ads to convince us to do things we probably didn't want to do. I do think that AI is helpful in some specific optimization areas. Like it might be helpful for code synthesis to come up with faster ZKP proof systems where there's actually like a clear objective function and we're pretty sure that optimizing that objective function won't destroy mankind by accident. So I would be interested on where I can help out there. I read one really cool paper on a combination of genetic algorithms and search for like sort of AVX style, like really high granularity x86 assembly optimizations that I think might be applicable to some of the cryptography that we're implementing. So that'd be cool.
Thank you.
Other questions?
Hey, just briefly for clarification for the end-to-end private bartering for V2.
Yeah.
What's the scope of that there for so that's without like a matchmaking node, with them discovering what they want, or?
It is with matchmaking, yeah. Matchmaking in the Anoma architecture is it's sort of a role. It's not like there isn't someone who's elected the kingly matchmaker. We're actually kind of concerned about like economic incentives. We don't want someone to be the sort of win-all matchmaker. So we're trying to build this kind of distributed matchmaking where if you are a node and like some of your friends send you intents and you can matchmake some of them but not all of them, you can like do a partial matchmake and then send that on. And someone else can do more of the matchmaking, but you've already done your little bit. So matchmaking is kind of a role that all nodes in Anoma, including phones, even in V2, hopefully, and edge clients in V2 will hopefully be able to play. Private bartering includes matchmaking.
Well, maybe I'm misunderstanding then the end-to-end private bartering part,
Right.
because then that is leaking some information.
Sorry, yes. End-to-end and private, end-to-end was like an adjective on bartering, not specifically an adjective on private. But bartering is roughly as private as we can make it, which is unfortunately an information theoretic problem. I mean, you could do something where you like only could test if two things which were homomorphically encrypted could be swapped, but not feasible. Right now in the bartering system we have, you have to reveal what you have and what you want, but you don't have to reveal who you are. And if you use like sort of mixed net network delays, and you are kind of doing things that people often do, like swap, commodities, then that probably doesn't reveal too much information. If you're doing very odd things, then it might reveal some. But you don't need to broadcast your intents to the whole network. You can broadcast them to specific people, and we're still working on ways of like facilitating that in practice.
Cool, thanks.
End-to-end in this case means like from making intents in an interface to them getting matched and settled on the system and someone else doing the same thing. Yeah.
Noted.
Other questions? Alrighty, I will let you all go. Cheers.